Good morning. The next 20 minutes, 30 minutes, I'll talk about measurement we made last year in 2010 in the Gulf of Mexico while we had the accident on the deep water horizon. RESON wanted to, together with a company called Terrasound, which is a surveyor company, try to sail out on the Gulf of Mexico and see what we could observe with our systems. And this is what this presentation is about. From RESON, we had Andre the shipper from our Dutch department and me. And then two participants from Terrasound, Steve McDonald and Jeff Wall. And they provided us with a good vessel so we could move around in the Gulf of Mexico. The agenda is as follows. First I'll present the sites where we observed the oil and where we collected data and what we could see by our own eyes. Then a brief presentation of the sonar installation and set up how we try to collect data the best way with the tools we had. And then some words about the processing methods, how we process the data and how we try to collect and extract the information as best as possible. Then finally results and a brief discussion and conclusions. This area up here is where New Orleans is. The Mississippi River is close to here, and we were in these four sites, and the depth ranges from 600 meters down to or up to 70 meters, and the deep water horizon was 2,900 meters. Okay, the most frequently observed substance that we saw was this orange dispersed oil. And it was, when we finally found it, it was everywhere, and it followed along the currents, and it was some really nasty patches. And I think that used all this chemical substance they put into the oil in order to make it sink. And you can see here on the left image, it contains also gas bubbles, and dead species are also there. And after a while you can see that it starts to sink, and on the sea surface is almost clean again. So that's probably the goal with BP, to have the oil sink as fast as possible. So what we don't see is good. See nothing, hear nothing. And in other areas you could also observe black oil, the crude black oil, which is, you can call it the real stuff. They have put no chemical substances into it. And while we were sailing, it was a really, you could see the surface was really thick. Yeah, and it did not contain any ripples. So the orange dispersed oil was much more frequently observed, and while the oil mixed with this chemical substance became grainy, from an acoustical point of view that would be great for us, because acoustics seem to work very well with the particles. But unfortunately, we did not have any alternative devices to measure the concentrations of oil and the oil as a function of depth. The only way, alternatively, we could observe the oil from the sonar was by looking at the sea surface. Okay, some words about the sonar setup we used. We used two multibeam systems. One, a forward-looking system, which would be shown here later on, and this is a downward-looking 7125 with the narrow beams, the kind of transducers that you use in hydrographic, and we have the 200 and 400 kilohertz projectors mounted here. So this was looking 45 degrees downwards, and the 7128 is mounted up here. You can see it on the next slide probably. This is here. You can see the 7128 is looking up a bit upwards, a 5 degree upward tilt. So the idea is that it looks forward, and we have an oil plume, and we sail into the oil plume, and we observe the oil by looking at scattering data. We only applied the 200 frequency system here. And here we just want to briefly mention the fact that you have the sound source located so close to the sea surface, and then we can have backscattering from the sea surface, which happens, but the most of the energy is reflected away due to the mirror effect. But since the sea surface is rough, we'll always have something coming back to the sonar. So that could be some kind of a false detection. If we imagine that was oil, that may just simply be the sea surface that we were watching. So that's something we should bear in mind while analyzing that data. And the downward looking was a 400 kilohertz 7125 system, and it has a very narrow beam. So this setup is a bit different. We are about 2 meters below the sea surface here, and this setup is not only physically a bit different, it's also different in the sense that afterwards the oil seemed to be lying only on the top of the sea surface, and we were not sure how deep it actually extended. So that was a bit annoying that you didn't know how deep down the oil actually extended. So this slide shows what kind of measures we had to take. We had to transform the scattering data into a zone where we somehow compensated for the volumes. A sonar system contains of several beams, and while we collect data in each beam, we get the samples in, and for each sample, by time the resolution cell of the sonar becomes larger and larger. So while you're looking out 100 meters, you will have a relatively large resolution cell. So you may have, say, a half cubic meter out at a long range, while close you may be in a 0.5 cubic meters or 0.5. So for each sample point you see in the data set, you have to compensate for the size of the volume. And this is what this slide is all about. We try to remove the effect of the volume. And in this case here we have an additional thing that we have to take into account, that the sea surface here is here. So the volume is not getting as big as it was if it was in the full water column. So we have to make some compensations here as well. Okay, and then we first look into the forward-looking system here, the 7128, with the wide opening angle. We have a 120 degree swath if we look down from above, and we have this 28 degrees vertical opening angle here. So we have a large area we look into, or large volume. And while we were sailing, we were just collecting data, duck, 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 ping, 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 into the cloud and out again, ping, ping, ping. And while we were doing that, we could observe from the vessel, there's oil there, and then we were heading toward the oil plume. And then we started to see data coming in on our sonar image. And to each ping, we just took the average value, and then over 3,000 pings or something like that, we plotted the volume scattering data for the cases where we observed orange dispersed oil, black oil, and seawater. And we can see that the orange dispersed oil is consistently higher than it is for pure seawater. It's about 10 dBs. And for the black oil, we had some really high spikes here, and down here, the black oil was mixing with seawater. And that may be due to the fact that you saw black oil on the water surface, but maybe 10 centimeters below the sea surface, it could be pure water again. So if the system is, if you only have water in the top layer here, you won't see any oil here because there's no oil. And it could be the case with the data seen here. Whereas for the orange, it's since I put some chemical substance into the oil starts to sink, and then the likelihood or probability that we will actually see a plume here is probably higher. Okay, this is another way to represent the data on. It's a so-called histogram where we try to make a distribution of the amplitudes we observed. And this is what we see in seawater, this is what we saw from the black oil, and this is from the orange dispersed oil. There's a clear discrimination between the orange dispersed and the blue, just as we saw on the previous slide. But this is what we saw on site, where this is probably an interface from going from water into the oil area, and we expect this to be something which is an water-oil interface, but again we don't know, but it correlated well with what we saw with our eyes. So then we take the downward looking approach, and this time the beam is much more narrow. This is a hypergraphic transducer, so it has very thin beam. Yeah, but the swath is 128 degrees like before. But this time we're not disturbed by the sea surface, which is good. And this time we also do not observe such a high difference between the water and the orange dispersed oil. Actually, it's about 2.5 degrees, which is no, not degrees, sorry, which is not much. But since these data are consistently higher, there are definitely something here in this area to see. Here you can see sometimes we got a really high spike here. And again, these histograms also show a clear tail here which is not present in the seawater. So next time, the coming slides will be what we call echogram, and just a few words about the echogram. If we have the wedge display here, the wedge display was something you saw here. This is the wedge display you see when you operate with your sonar, even though it's at strength 125, it's at 128. If you take this wedge display and sum all the beams into one time series, you get this one here. So this, you transform one ping into one time series or range series here, and you stack them with ping number. You can get a plot like this, and this is what you get from the seawater, and this is what you got from the orange dispersed oil. And it's not very clear here, but this is depth, and this is depth below the sonar head. So we are already here at 2 meters below the sea surface. So we see something here at the orange dispersed oil. There's definitely something here. There's no doubt about it. What we see here compared to that is more fuzzy. But it's another way to represent data and gives a good visual fast inspection. So the orange dispersed oil is definitely much more clear in backscattering than the black oil is, and it appears more frequently. We did not have any alternative systems to measure the oil or characterize the oil, so that was a bit frustrating, because if we had some laser systems and we could descend them, we could really go into and quantize our data much more. But that was what we had at that time, and we had to act fast because the pollution was evolving constantly. So the conclusion is that we can, with our system, we can discriminate between pure water and dispersed oil and polluted oil. The problem is, of course, that the next time we'll have an oil accident, the scenario will be different. So we cannot just say that we'll be able to observe oil, but we can say that with very high likelihood that we will probably detect oil very soon. So sonar systems can be applied for that. Okay, thank you.